We're very honored and pleased tonight to have Dr. Iain Stewart here with us to deliver a special guest lecture. So Iain is a professor of geoscience communication at Plymouth University in the UK, and by that I mean the other UK. But he has a really wide range of scientific research interests. They include hazards like earthquakes and volcanism and tsunami and abrupt environmental change. But maybe one of the most interesting things about him is that for the past 15 years or so, he spent a lot of time working closely with the BBC to host a series of television documentaries on the nature, history, and state of the planet. He's a very honored geoscientist. He's received awards from the AGI, the European Federation of Geologists, the Royal Society of Edinburgh, and the Royal Geographical Society. But tonight he's here on a specific mission. He's the 2017-2018 James B. Thompson Jr. Distinguished International Lecturer for the Geological Society of America. And the lectureship is named after James B. Thompson, who was a very well-known professor at Harvard and left an endowment to GSA to fund a very interesting dual international lectureship. So Iain is an international lecturer who comes to North America. There's also a North American lecturer who goes throughout the rest of the world each year. And the goal is to increase the visibility of the international sciences and emphasize the globalization of the geosciences. And we're also taking the opportunity to resurrect the Donald Haney lecture series at KGS, which actually started in 1988 and was suspended for a bit in 2012, and we decided to resurrect or reinvigorate it. This year, as some of you know, some of you may not know, Donald Haney was a state geologist and director of KGS from 1979 to 1999. He died several years ago. He was very influential and left his mark on KGS. Among other things, he was largely responsible for the new building that we have, a relatively new building. So we decided we're going to resurrect the Donald Haney Distinguished Lecture in Applied Geology. So that is also tonight. Iain's topic is going to be Between a Rock and a Headplace, Communicating Contested Geoscience to the Public. So Iain, thank you.
Thank you very much. Thank you. So, fantastic. It's a pleasure to be here, fighting through the snow. Well, that was you fighting through the snow. I had a relatively easy drive down from Cincinnati, so I appreciate you taking your time out. So, and what I'd like to talk about is, I suppose I should explain a little bit about the background, because I'm not normal. I mean, geologists aren't normal at the best of times, but I'm even more not normal. So my PhD was in kind of structural geology, geomorphology, looking at neotectonic faults in the Mediterranean. And I've mainly worked in kind of that very recent geological change in that region, a little bit in other things. But yeah, about 2003, I started what became a really strong partnership with BBC Science. And for a while, I had a kind of dual world of the normal academic stuff, of research, teaching, and admin, and then alongside making television documentaries for BBC on planet, how it works, what it means to us, kind of stuff. And then about 5 years ago, I brought the two together because I was trying to juggle these two worlds. And so now what I do is I'm interested in what I call communicating contested geoscience. So what is the bits of geology or science, whatever we want to call it, that's really controversial for the public, that public interface with geology. So climate change, fracking, rad waste disposal, earthquakes. And so it's trying to bring to bear the kind of communication side into that world. And particularly interested in how we do it as an interdisciplinary workings, and also how we do it in terms of training, in terms of graduate training. So yeah, I mean, the reason is that if I said to you, do you think geology is of critical importance to addressing many of the problems that face society in the 21st century, I'm sure everyone here would say yes, geology is of crucial importance. But actually, if you look at what those issues are through things like the UN Sustainable Development Goals, geology isn't really obvious. Most of the kind of key things like goals don't seem obviously overtly geological, and yet we recognize that, you know, if we're going to be building the cities of the future and more people are living in cities, then that requires, you know, ground engineering expertise. It requires us understanding where we go for the resources for those cities, a whole bunch of other things. The minerals, in terms of minerals and metals, resources to basically continue to kind of push the modern world. The modern world relies on geologists going out and finding stuff to kind of keep itself going. Energy, well, we know we've had the run on fossil fuel energy, but there's a transition going on in place. And how does what is the role of the geoscientists as we switch into the renewables? And things like geothermals, pretty easy to see, and things like CCS for fossil fuels. But what about these other ones as well? What's our place with that? Clean water, geology is pretty crucial for that in terms of hydrogeology, particularly groundwater, climate change, environmental pollution. All of these demand a real kind of detailed knowledge of geoscience, of the subsurface in many cases, and yet geologists don't tend to be involved in, for example, sustainable development, seen as someone else's game. So I'm interested in this. I've been pushing this notion of us being, it's kind of geology for the public good. It's about taking these skill sets that we've got, this great understanding of the planet, and thinking, well, how do we use that to actually make meaningful change to improve human well-being in the long term? I don't care what we call it, but it seems to me that it's become more important. And within the core of that then is communication, because essentially what it requires the geoscience community to do more than ever before is to kind of sell itself as to why it is going to be critical in this new arena. Many of the other sciences have got in there first, and kind of geoscientists in general are kind of chasing the game a little bit. So, as I say, that kind of explains a little bit my motivation to move from straight geology into this nefarious world of geoscience communication. But I should say something about what I mean by science communication, because it means different things to different people. So the way that I kind of explain it to myself as much is in this plot here, whereby if we look at this vertical axis, we go from why are we doing the science? So down here is we're doing it for pure knowledge. So this is pure blue skies kind of research. And all the way up here is kind of user-driven or problem-driven research, applied research, if you like. And then along this axis is the level to which we've involved the public. So down in this little corner here there's not really much involvement. This is pure science. We go to research conferences. We write research papers that appear in behind the paywall journals. And it's very much about serving our own kind of academic community. If you go across all the way to here, across in the bottom right, well, you've got something like citizen science, so get the public involved, but actually the public are involved to collect some data that's going to be feeding some research project. The public aren't intrinsically necessarily interested in how many hedgerows there are or how many, whatever. Up here, policy reports, well, this is, again, part of often our realm, which is that we are writing something on induced seismicity or something that seems to be of the public realm, but we're not really involved in the public. And as most academics kind of start in this area and kind of drift over in one of these axes into this realm. And the way that I see this really is that this bit down here was what I call the kind of make and sell realm. So if you take, this is an analogy that comes from kind of an economics marketing paradigm, companies that make stuff. You think about your production costs, that's what you spend all your time making your product really good, and then you send out the door, and you're not really thinking about your customers, because if you've made a nice enough profit at a low enough cost, someone will buy it. And so I think most of us are in that. Science, we're making science, we're producing science that we think is important, and we're putting it out there for the public, and we want to communicate it with public talks, or we write articles about it, or we maybe encourage the public to come in and have some kind of debate, but we drive the agenda for that bottom left corner. But there's the top right corner is what in many of the businesses they refer to as sense and respond. And that is when the customer is king. So those are businesses that ask, what does the customer want? And when they hear that, they then change the product line. So your Apple, for example, constantly thinking, what does the customer want? They want it bigger, smaller, flashier, simpler. Right, let's change it. And the thing is, academics don't really occupy that realm. Sure, the public own, but we don't really like them setting the agenda for the things that we do. And the point that I'll make here is, interestingly enough, I think television science is an area whereby I think that's the edge of the place where the academics will be involved, because television program makers are listening to the public, and they're saying, we want to do a program on X, and sometimes scientists will be drawn into that as a contributor, in my case, a host. So I'm kind of interested. But the end game really is that we end up somewhere in the middle here as what Roger Pielke Jr. refers to as the honest broker. So that is someone a scientist who is basically kind of gives the public options by exploring different things, trying to be transparent and explaining the science and listen to the public back to know what the public think about that. So it's a kind of a mediating arbiter of truth, if you like. So what I'm going to talk about really is why I think the problem we have is that we occupy this area too much and that we need to shift across into this realm and possibly even into this realm. Within science communication, there's a whole paradigm change now. The way we used to think of communication, which is that the public are empty heads and we just need to fill them with knowledge to educate them, has actually failed time and time again to actually deliver what we need. And so there's a move now to be much more participatory, to bring the public in to the discussion on what kind of science they want. So this is kind of sweeping through science. And we see it in climate change research, we see it in the Sendai Framework for Disaster Risk Reduction, we see it in the United Nations Sustainable Development Goals, etc. So I'm kind of interested in this balancing act between the two, and I'll come back to this right at the end. But, so my story, from about 2004, I've started these kind of set of programs, really, that I've, in different ways, just taken geology, taken the Earth, the planet, and pitching it in a slightly different way. So some things are just generally about the planet, Earth, for example, how Earth made us. Climate wars and Hot Planet were about climate change. Some people know this one, Men of Rock, which was a bit kind of the history of geology, particularly Scottish pioneers. And then increasingly and recently, energy. So fracking, did a program on fracking, 3-parter on oil. And really, this is the kind of moving into this slightly more contested area of science, slightly trickier bit. One of the things that happened when I started doing television is that television has a great way of ripping you out of your discipline, and you can have this almost out-of-body experience when you look back at your discipline, but from a completely different place. And so time and time again, I was confronted with things that I didn't understand because it was outside the kind of ken that I'd had up until then. So anyway, just a couple of examples that were really influential to me right at the start about trying to think this communication business was pretty critical. Mount Merapi, Indonesia, a really nasty volcano, the Merapi-type volcano. It's got this congealed mass at the top, lava dome, which then kind of spills down into pyroclastic flows, often kills several hundred people at a time, and down into this Yogyakarta plain, which has got about 1 million, 2 million people, depending how you measure it. And we climbed to the top of here, and at the summit, here's Rudy, here's a volcanologist, was telling us about the monitoring equipment that they have. And because of that monitoring equipment, they can give hours to days warning. And that was all fine. We filmed that, wrapped it up. We're coming down the hill. And Rudy said, oh, of course, the odd thing about it is that we have these mandatory evacuations. But the people at the upper flanks, the villages in the upper flanks, don't evacuate. And I thought, well, what's going on there? Because volcano science is very well evolved in that process, unlike my kind of earthquake science. And he said, well, it's probably something to do with the kind of cultural connections. The people there have this belief system that when their family die, they get taken into the volcano, so the volcano is where their ancestors live, and they'll give them warnings. And I thought, that's bonkers. That's absolutely mad that we've got a science that's so well evolved and it's getting undermined by this weird kind of cultural affectation. So I came back, we got a PhD student working on this. And what was really clear was it doesn't work. This is Mar Barajan, who is the spiritual gatekeeper of the volcano. His job's to commune with the volcano and to pass messages on. And this is the village of Turgo, where in 1996, there was a mandatory evacuation in place because there was a volcanic crisis. The people of Turgo didn't evacuate. In fact, they actually held a wedding on the Saturday night. The pyroclastic flow came through the church hall, the community hall, and killed 40 people in that room. So clearly this indigenous knowledge wasn't going on. Now, Mar Barajan explains this by the fact that the people of Turgo had held the wedding on an inauspicious date and had been punished. But the point was that clearly there was a kind of decoupling. Now, it turns out to be a lot more complicated. When my PhD student spent working with cultural geographers, worked in there, it turns out that the main reason people don't evacuate is because their main livelihood is cutting down grass, feeding it to their single cow, and basically selling the milk from the cow. So the reason they don't evacuate was because they said, well, I can evacuate, but who's going to evacuate my cow? And they're making a rational decision that their family's much more likely to come to harm with something happening to a single cow than a pyroclastic flow happening through the village. And I think that's perfectly rational judgment to make. It's just not the judgment that hazard scientists are making when they're setting this thing up. The assumption is they're going to follow the kind of the science. And actually what we see is that they don't. They behave in a very different way. A very topical example given the last week or so, but La Conchita in California, just south of Santa Barbara, north of Los Angeles, in January 1995, there was a landslide. You can see the back scar here. And then in January the 10th, 2005, that big rainstorm remobilized this landslide, and there was a mudslide that comes all the way down here. And I went there in December, and we were, Jeannie here lives in this house, and she walked me up this street and told me about the mudslide and how the mud had gone up to this level of our house. The emergency service used that window to access it and to dig the body of Charlie, our best friend, across the road. And I say that very deliberately because that was the very first time that I'd heard someone talking about a disaster that actually had their names and were telling me about it. You know, in textbooks, it's, 20 died or something like that. So this was very influential on me. Anyway, we walked up here, and we got to just underneath that tree's a house, and the house was for sale. And I said, well, no one's going to buy that house. Because you open the curtains and you see crosses across the road. 10 people died in that. And so the USGS study of this, along with the other engineering studies, have said the same thing. The next time there's a high precipitation event that dumps a lot of rain on that slope, it's going to remobilize. It's not rocket science. And Jeannie said, oh, that house has been sold and since the landslide. And she said, actually, it's gone up in value since January. And at that point, I thought, I really don't understand hazards. Because the point was I didn't understand people. So that Jeannie is smart, and she's affluent enough to be able to move out. And she's read all the science stuff, and she's not moving. And about 50% moved out, but 50% stayed. So what I realized was I'd been teaching hazards for 10 years, and I really didn't understand them because I'd only been teaching that from the kind of physical geoscience side. There was a whole other dimension that I really didn't understand. So the thought I didn't understand was this lot, the public, And because I'd never thought about them. I'd never had to think about them in my geoscience world up until that point. And what's interesting about television is television never stops thinking about the public. It constantly thinks about it, probably too much. It's got necessarily focus groups, it's looking at audience ratings, in my case, it's got producers and directors who say things like, I know what a BBC Two audience is. I know what the viewer wants to know now. So they're always thinking this way. So it got me into a whole literature, really. There's several decade-long empirical literature there from the social sciences about people and how they make decisions and how they react that I didn't know about, that I had to sort of learn fast. As a way of summarising that, I'm going to use this particular study. It's a CSIRO, so the Australian Research Organisation. And it's called Community Attitudes to Science and Technology in Australia. It's downloadable as a PDF. I encourage you to have a look at it. But although it's Australian, I thought it's useful. It's a country that's got a lot of geoscience. It's very applied. And it's a nice summary of this kind of empirical data set. So if there's any social scientists in the room, what I'm going to say now is not a surprise. This is something that's completely just well-known and understood, really. What is slightly odd with the Australian study is very Australian. The names are kind of a little bit kooky, and I wouldn't believe the numbers as far as I could throw them. But the point is the actual general message. So the first thing is, if you think about the public in terms of their attitude towards science, then you get different sets of people. So one lot, about a quarter, let's say, is science fan boys and girls. You are science fan boys and girls. You've demonstrated that by going through the code on a Wednesday evening to get to a science talk. So you must be in this category. You might not feel you're boys and girls, but bear with it. So that is people who feel close to science, can have a discussion about science, will watch science documentaries, will read science articles. You're pretty okay on science. And then there's the Mr. and Mrs. Average. slightly older, slightly more distant from science, but still science is resonant with them. They'll watch maybe the odd documentary, probably wouldn't read a science article in a newspaper, and they might be having a conversation with science and would kind of realize quite quickly they don't quite remember as much as they thought. Then there is the I wish I could understand group, which is small in this one, but actually it tends to be slightly older cohort, but they're the most science consumption. They're the ones that go to museums a lot and science centers, and they get very frustrated because the science they see there they can't connect with. They don't understand it. It's not portrayed to them or projected to them in ways that they can understand. And then there's a group that says, I don't like science. And this is quite a small one in this one. Other surveys, that kind of equivalent group tends to be bigger. They hate science. Something horrible happened to them in their chemistry class and they never recovered. And their kids come home and they say, I need to help with the science homework, and the hairs go back up in the neck, and they absolutely would not watch a science documentary. And then there's a group that's, again, in this one quite sizable, that says, it's nothing about science, I'm just interested in other stuff. I'm interested in politics or music or art. I don't have time in my world for science, not against it or for it, it's just the way it is. And then finally there's a I know all I need to know, and this one quite a small group. It says I don't need to know about science because I know how the planet works. It could be religion, it could be pseudoscience, it could be whatever, but it's not. I don't need to follow science to understand what's going on around me. So this is audience segmentation. And different groups do it, advertisers will do it, television people do it, but actually the group that doesn't do it is scientists when they're talking to the public. We don't think about this in terms of our audiences, of who we're trying to reach. If you're communicating, a good communicator thinks exactly who's the audience that's out there they're trying to reach. So if you're trying to communicate to everyone, that's not very effective and you're probably going to fail. So usually what you do is you target a particular subgroup. So in my ones, the most obvious one, well, who do you think? Who should I target? So I've showed you a little clip. Mainstream audience that I'm trying to get. Who are the most important cohorts? So this way, so across here, these first three. Yeah. Anyone?
Science.
What's that?
I try to target the I don't like science people.
These people? Okay. So we should grab some of them. Any other thoughts? What about the too many other concerns then? There's nods there. We're in danger of having the whole of the public now. So let's simplify it. Do we need to get this lot?
I know there are.
Let's scrub them out. They're going to write to me in red crayon telling me gravity's wrong anyway. So I'm not going to get them. So let's take an easy one. So this group seems, they're desperate for science portrayed to them in a different way. So should we agree? So there's, and what about this group, Mr. and Mrs. Averaged? Yeah, I think they're kind of a strong group. These are interesting because this group, I don't like science. If you can portray science in the way that they wasn't like at school, then you'll get some of them coming across. So I think trying to think about them, this might be the core, but trying to think about these, and a similar fashion there, if you can make science of concern to their concerns, then you can say, actually, that is important. For example, in the oil program, Planet Oil, the second episode was about, so for those interested in politics, was about the role of the UK and BP in overthrowing the Shah of Iran, or in Iran, bringing in the Shah way back in the kind of 50s. So the geopolitics of so that's really kind of important. Which actually then says, well, what about this lot? I already have you, absolutely. Yeah, I don't need to design my program for you guys because you will watch. And I apologize for that. But it kind of explains why when you're watching science programs, you get frustrated about those programs because of all of the repetition, the lousy noise, the fact that the host is doing a bunch of stupid stuff. And you're going, I don't need this. And it's true. You don't need it, but it's not for you. It's for these other groups. So one of the key things I usually say at this point is that the kind of stuff I do is not education. It's entertainment, first and foremost. And then if it achieves that bit, then find education after that. Because it's really trying to take it into this realm. We're really good at that realm. That's easy, and we spend a lot of it time. That's usually our make and sell realm, but actually getting into these ones is much harder. And it's kind of going to the right, it's what I'm trying to do. So the other thing that's interesting, really, is that same survey looked at what is actually beneath the attitude. So what are the fundamental values and belief systems that kind of underpin this? And that's harder to get at. And the way they do get that, social scientists, they ask value-laden questions. The benefits of science and technology are greater than the harm, or science tends to benefit the rich more than the benefit the poor. So it's trying to bring out the values of the individuals involved. And in terms of this, the study identifies 4 value-laden groups in terms of science audiences. And this is an increasing order of interest in science. So up here we have one, the science fans. Science is good. Science is a panacea for solving the problems of society. It's not happening too fast, it's not too scary, it's a good thing and should be supported. We've then got another group down there that says it's cautiously keen, which is, yes, science is broadly good, but there's some bits of science that I don't think are good or maybe are a problem or I worry about. The risk averse is kind of a conservative with a small c. It's, the world used to be a nice, simple place. Science is technology is just making it really turbulent. Why can't we just go back to the way it used to be? And then we've met this lot, so the concerned about science, so science is bad, or the disengaged, which is I don't care about science, neutral. So what I'm going to show in this space here really is a set of plots that kind of show those values for some of those questions. The questions themselves are not that important. It's kind of a pattern recognition business. So here it is. There's something I think that's interesting about you lot, us, green. So what is it that I'm getting at here? Yeah.
Science fans are on the more negative side for some of the issues?
Not quite, because they're obviously the last one is the opposite way.
Yeah.
You're getting it. It's close to it, though. What do you think?
Science causes problems even though we believe in it?
Don't drill into the detail. It's simpler. You're being too analytical now. Yeah. Just shout.
Science leads to more questions.
Not quite. That's an interesting one. I've not had that one before.
You think those are all society problems?
Don't, look, forget the left-hand side. Forget the titles. Look at it as pattern recognition. True. That's a kind of flip side of the one I'm looking for. Yes, that's the ultimate extreme version. It's that we're decoupled. We're at the edges for a start. We're at the more extremes. In most of these, we're decoupled from the other value-laden groups. So, for example, B overlaps with C, shared values in there, D with C. Even B with D in some cases have shared values. But the science, that science fans group is disconnected in terms of their values from those other groups. So there's a paradox here that as a cohort, we're the ones who think science is a good thing for society to address the problems, and yet those values that underpin that aren't shared by most of those other value groups, and our ability to connect on a value-based things with those other groups is probably impaired. So the conclusion to the Australian study is, first one's this. When information is complex, people make decisions based on their values and beliefs. So if they're wanting to know about fracking or they want to know about climate change and things like that, the stuff's all out there, they could go and read all of that technical knowledge and listen to it, but that's not what they do. They have an instinctive view of how they do it. And it's the exact same things, the way that we make decisions about whether we want to buy a new television or a new car. We might go through and do all the stuff, or we might ask George up the road who went through it, and George is a pretty smart guy, and we could ask George, and George says, this. So we have these shortcuts. So we often make those decisions. And this is non-technical audience asked to be decisions about technical stuff. It's not about an engineer or asking a scientist. This is your kind of public lay groups. So following that then, people seek to confirm those attitudes and beliefs, no matter how weird they are. So if you think that the planet's hollow, for example, if you're a hollow earther, I could see someone up there agreeing. Yeah, if you think the planet's hollow, worry what you're teaching here at UK, but never mind. You will be able to go into the internet and you will find people, and probably on the other side of the country, maybe in deepest, darkest Oregon or somewhere in a wood cabin, who shares that view. And you go, I blooming well knew it. Look, the planet's definitely hollow. The fact that you've gone through 99% of material telling you it's not on lots of is completely irrelevant, because that's not what you're doing. You're trying to reaffirm your beliefs to show that you are correct. Your intrinsic gut instinct is correct. No one likes to have that questioned. People most trust those whose values mirror their own. That's the issue to do with that previous one. So in the Australian study, they said, if you're not going to trust scientists to tell you about science, who would you trust? They said friends, family, and radio hosts, radio commentators, because they're the people they listen to all the time and they take viewpoints on. So the fact that we don't share those common values with many of these other groups mean that we can be just tuned out because we don't share those values. Therefore, it's actually not worth us listening to, because they're not thinking in terms of scientific knowledge and information. They're thinking in terms of values, value judgment. Attitudes that aren't formed by logic or facts aren't influenced by logical or factual arguments. That's the obvious conclusion. If it's people are making decisions based on the values and beliefs, they're not making it on factual information. So us providing factual information doesn't help. And that's one of the areas where we're absolutely fixated. In terms of standard science communication courses, we talk about getting the science, the knowledge better. How can we get rid of the jargon and put nice, simple language? How can we get nice, simple diagrams, drawings showing it? All of that's about a clarity of information. But actually, if it's not information people are wanting, then that's not really help. In fact, the final conclusion of the Australian, and again, this is this review of empirical stuff, is that public concerns about contentious science is almost never about the science. And therefore, scientific information, therefore, does little to influence those concerns. And I think those last two are the real tricky ones for us. Because if there's one thing that we do in places like this, it's train people in clear scientific information and knowledge, and we send them out with the assumption that's going to work, because it works for us. It works for our green group. So when we share information, and we share information with other technical people like engineers, that's exactly what we want. And we kind of assume that must work when we go into the public, and it doesn't seem to. And the scary bit there is, well, if we can't have logical, factual arguments and information being what we communicate to the public, what are we going to communicate? What do we have? And that's a much harder thing to think about. So I now want to go into a couple of areas of what I call contested geoscience. This is a quadrilla site, a fracking site. So you guys have got a long history of looking at shale gas, unconventional shale gas. This particular site, the first 6 hours of unconventional gas drilling in the UK triggered a magnitude 2.2 earthquake and ended up getting a moratorium that shut it down. I think there's tens of thousands of fracking jobs in the world, of which I think they've triggered something like 3 earthquakes, 3 actually slip-on faults. Well, one of them was in the first few hours of the UK shale gas exploration. So one of the things that I'm interested then is, if we're going to communicate, one of the things you need to think about when you communicate is, what does the other people know? What do they want to know from me? And what are they already thinking? So one of the things, the question we've been having is, well, what do people think of the subsurface? So down in the southwest, I'm from southwest England, well, I'm from Scotland, but I live in Plymouth in southwest England. And that's mining country, tin mining in Cornwall. So this is a tin mine, and so I had a PhD student who was working on this with cognitive psychology, said, what do people think is in the subsurface? And the way that she did this was, that Hazel did it was with this thing called a cube, because the point was very quickly she realized they didn't have the language to even speak to people about the subsurface. So the way we got around that was she would interview them, but she'd ask them to draw. What do you think's down underneath your feet? So that's a 5 kilometre by 5 kilometre surface area of their area. This is you can see a mine. It's a kind of china clay pit above the granite. And so she'll ask them to draw this. And she also, it's called a mental models approach, she also asked experts. Here's an expert model. Seems a little bit cartoony, but actually the interesting thing is, well, there's a fault on there, but it's not just a single line, it's a zone, an anastomosing zone, which people will appreciate. There's scale on there, kilometre, 5 kilometres, granite, kilos, which is the country rock. And interestingly, the fault appears on this side. All of the geologists used at least 2 sides of the block. Not a single member of the public used a second side. They all did it on a one-dimensional side. So already we're realizing that our 3D thinking that we teach all the way through is setting us apart from the way that normal people look at this. So let's have a look at some of them. So this is someone who's been, this is for their interview, you're talking about going down hot rocks, getting hotter. I love this last bit. Decent miners, a lot of the miners there, they're virtually nude because it's so hot. They've got these images of this high geothermal stripped to the waist, plugging away at the rock. And at first glance, you think that's a pretty good model. You've got the mine system here. There's hard rock, granite, Devonian. There's veins of tin, copper, zinc. And Hazel said to this person, well, that's the human subsurface. That's the mine. What about the rock? And she picked up a red pen and she wrote dark. So there was a very sophisticated view of the cultural subsurface that they'd been brought up on. But when asked about the geology bit, our world, if you like, it was completely blank. Here's one talking again down to the very bottom of the earth. That's where it's all broken down. I presume that's where the heat of the earth is. There's a ground surface there. I don't know why we got another ground surface, but then a series of layers, and they're reasonably, in order and things. What do you think that is? That's the Earth's core. Yeah. So they drew it circularly, and then they said, oh, no, that's ridiculous. And then they went, no, it's more like that. So, for us, if it's a 5 kilometre by 5 kilometre, then that's what, 3 kilometres to get to the core? Interestingly enough, one of the objections of we just had a deep geothermal project in this area. And one of the objections early on was, I'm worried that if you drill into the granite, this is Variscan Hercynian granite, then the magma will burst out. And we had a giggle about this as we drove back. And then I thought, well, actually, that's telling me that someone knows that granite came from molten material. It's good. And then actually, we're going for hot rocks. It's geothermal, so it's hot down there. So the only thing that was kind of laughable was not knowing what the melting temperature of granite was and the geothermal gradient. And I think some of my students wouldn't necessarily know that. So the funny thing is, those are things that are so obvious to us, but then putting it into the public, where would they get that information from if it's not from spending years in a classroom like this understanding? And it was pretty clear then that other people just were really confused. So this is just a set of layers. I think that says 70 degrees down here, warm. Some people couldn't find themselves to draw it, and the most common reaction was a kind of rigor mortis of, I don't know what to do. I don't know the first thing about what to do. That was the most common one, is I can't draw anything. I don't even know where to start. Some people just put some pictures down. That's pictures of granite. This one's an interesting, these are buildings. And Hazel said, well, that's buildings in the earth. And they said, oh yeah, but the mining was a long time ago. So that notion of people digging down and they're excavating their cellar and finding buildings from the 18th century was a suggestion that kind of thing. So that the gulf between the way that we see the world and the way that, now remember, this is a mining community. These are people who, almost every member of the families have gone down into the subsurface. What would happen if we tried this in London or Birmingham? What kind of cultural disconnect would we get with the subsurface there? So this leads me to think that the gap between us and the public when we start communicating geology is a chasm. It's absolutely huge. And we really don't understand where the public is when we actually start to think about this. So here are the two views of the way that I think people see the subsurface. On the left, and they're kind of in a funny way mutually compatible. In the left side, it's a wonderland down there. It's Antarctica buried. It's this beautiful, untainted world, and we're drilling into it and fracturing it and breaking it up. Or it's actually a dangerous world down there with lots of toxic stuff, maybe natural, maybe not, and we're allowing that stuff to come up into their world. Neither of those are especially good for geologists thinking about going into the subsurface. So we try to look at this in terms of, because for the UK, and I'm sure it's the same here, geothermal's come along, we've got a lot of stuff on conventional gas. CCS is now getting picked up by the UK government, it's getting pushed, and we're just about to go into a new round of looking for a radioactive waste site. And all of these are issues that requires the public to have a say. They're mandated as part of the democratic right to have a say in what happens in the subsurface. So the extent to which there's this disconnect is really troubling if we're going to start to do this. If you're interested in this particular one's our Science Review paper that came out this year that kind of summarises a lot of this. And the mental model stuff is, again, that's open access. But So I want to shout to something completely different. Most of the stuff that I work on is earthquakes. I've been working for many years on one of the big earthquake problems on the planet, Istanbul, Turkey. This is the Hagia Sophia, a really fantastic, famous kind of museum now, but mosque, church, built 600 AD, around about then, and almost immediately part of it was knocked down by an earthquake. In fact, what you can see is all the stone buttresses basically been built afterwards to hold this thing up. That's as close to a pyramid as you'll get in the Islamic world. So that building knows that Istanbul, Constantinople at the time, is affected by really big earthquakes. But very little of that city does, because most of that city has really appeared in the last 50 to 60 years. And there's now 13.5 million people in Istanbul, and it's not had a direct strike for centuries. The reason to worry is shown in this one here. It's the background of Istanbul is up here. This is the North Anatolian fault line. It's kind of our San Andreas. It's a little bit simpler than San Andreas, but more linear. And the key thing is an extraordinary set of earthquakes. It started in December 1939, rupturing this section. Then 1942, ruptured here. 43 here. 44 there. They've missed a little bit in here in 51, fills that in. Then 57 just there. Then 67. And then in 1999, an earthquake here really brings earthquakes to the kind of gates of Istanbul. And if you go back a little bit more, you find there was a big earthquake in 1912 over here. The result of that is the only significant segment of the North Anatolian plate boundary structure that's not ruptured in the last century is the Prince's Island segment here in the offshore Marmara Sea. You can see the bathymetric scar here, so it's probably going to be tsunamigenic. There's a catalogue of historical damaging tsunamis in this region. Fault length suggests that this is capable of a magnitude 7.4 plus earthquake. And although this coastal area here is got almost all the industrial plants, harbour systems, power plants, chemical works of that very industrialised corner of Istanbul, the main worry is that 20 kilometres away, you've got a city of nearly 14 million people. So the city is a hodgepodge of very old buildings, but and very modern buildings. But the bulk of those buildings were built in a massive phase of urban growth in the last 60 years, from 1930 through till about 1990 was when Turkey had its industrial revolution, and that was mainly funneled through Istanbul. So a lot of buildings built fast without really any planning consent. So what I'm interested in is how do you start to, what goes through people's heads if you're starting to think about something like this? Because one of the issues we have is, although the hazard in Istanbul is extremely high and the vulnerability is high, so therefore the risk is, the level of seismic preparedness, so the level to which people have tried to prepare themselves by having emergency kits, by knowing what to do, by thinking of their houses and fixing stuff in the houses, by knowing what the emergency plan is and where mobile hospitals. If you take these indices, then Turkish residents are less likely than almost any other place that's got earthquakes to have those changes, certainly compared to Japan and US. So here is a study that's been done by environmental psychologists in London, UCL, that are looked at US, Turkey, and Japan in terms of the earthquake psyche. So what is in people's heads about this? And there's some things that are common. All three earthquake-prone populations are have fatalism, which basically shrugs the shoulders and says, what can we do? We know there's going to be earthquakes. There are also very high levels of, this is the number of code indexes for this vertical axis. So it's kind of the psychological way of coding. They're also very aware. They know there's earthquakes. They're not stupid. They're very aware there's earthquakes there. But there are interesting differences with Turkey. Here's one here, a large religious component that actually argues that earthquakes are acts of God, and therefore presumably it's presumptuous to say when an earthquake might come or to make preparations. But the real killer one is this one. The notion that earthquakes, or at least the disasters that befall them, are acts of people. And let me explain what that is in this next one, because this is kind of the psychologists drilling in through interviews with people about what's going through their heads. What have they got? Well, in all those places, an anxiety, a fear of earthquakes, which is perfectly reasonable. Turkey, very acute sense of isolation and sadness. and a very acute sense of vulnerability. I suspect for what's coming in a second, but also because they saw an earthquake in 1999 affect buildings exactly the same as the ones they've living in, demolish. 18,000 people were killed just 2 hours down the road in that earthquake. Demise of identity is this kind of sense that Turkey going down the tubes, and this was from 2013, but anyone who knows that area politically knows it's a very contentious country at the moment in terms of lots of stuff happening. But here's the things that I think are key. Very high perceived level of corruption. And it's not just perceived. If you look at Transparency International, etc., there is a very high level of endemic corruption going on in Turkey. Very high blaming of big business, that corporate business is running the show, and that's kind of squeezing people out, that the civic authorities are not taking the responsibility, and finally, of deep anger. These are protests about about districts, old cultural districts, mainly low immigrant, poor housing areas, being demolished to build new skyscrapers, new multi-story blocks that are resistant to earthquakes. The reason they're protesting is because their old historical centres are being demolished, and in place they're building new multi-story where most people can't live in because the rents are too high, so a lot more people come in. It's not built by the civic authority, it's not built by public money, it's funded by private money. So to make the economy work, you have to put more people into those at-risk places than were living there before. So the view is, well, if those buildings, these new builds, stand up to the next earthquake, then that's a good thing. But the worry is that the levels of endemic corruption, etc., means that they may not. They may not have been built properly, and if they collapse, they're collapsing with far more people in them than was originally there. So the only acid test for this will be the earthquake, and that's really troubling to those people. So one of the things that we did, we had a science communication course as part of an EU project called ALERT. This is my PhD student, she's a visual anthropologist, and we took a bunch of PhD students that were geophysicists and geologists, tectonicians, pollen analysis, sedimentologists, etc., that were working in different aspects of tectonics, walked around these at-risk districts, low neighbourhoods with social sciences, an urban historian, and really confronted the geologists with the notion of what the earthquake actually is. So the way that Omer here sees the earthquake is very different to the way that we see the earthquake. The earthquake is only bad. There's nothing good in an earthquake. And yet for us geologists, earthquake's where we get our data from. And you still get that sense of excitement when you hear there's been a really big earthquake, because you think, oh my gosh, the world's going to be looking at us suddenly. They're interested in what we do. But also there's data. We'll understand more about that area. It's not completely gratuitous. But for this guy here, earthquake is only bad. There's nothing good about that. And we went to a local neighbourhood association in one of the areas where the houses are getting tipped down. And he says, you know what? I've never seen a scientist here. No scientist has ever come to me. He said, I don't think there's an earthquake area, a risk in our area, because in 1999, in my district, 3,000 people died in Istanbul in that 99 earthquake. He said, not a single house in this district had a crack in it. And yet they're now pulling down the things. He says, I think what it is when they pull this down, they're going to build a shopping mall here. And they're just going to make money. It's just like a land grab under the guise of earthquakes. And so here's the problem. Look at the faces of these people here. Now, that's not boring, boredom. We wrote a paper up talking about the responses. These are people who have been studying earthquakes for about 5 years and have never actually thought about the earthquakes in the way that Ali here is thinking about them. They've been forced to think about the ethical aspects of what it is to be a geologist, of what their responsibilities are to Ali, to the public, etc. And I think that's a really important thing that we ought to be doing more of. So we wrote this up as a paper, but I think the key thing here is that the geoethics of our role in society as we start to tackle these really important issues for the wider world out there, it's really important that we start to think about some of this stuff. So where's David? Is David in this shot? So can't see where David is. Oh, there's David. So that guy came back and said, we had the workshop in the afternoon. What should we do for Omer and Ali? He said it's really important. We need to get in there. We need to get into those communities and tell those people what to do about earthquakes. They're not getting any information. It's all going through the official authorities, and the official authorities aren't trusted. But we have this guy here, Chris, and we have this guy, and they said, absolutely not. We are scientists. That is our job. We do the science, we write it up, we step back. Because if we lose that independence, that neutrality, we have nothing. So that's a huge debate, and that's fine. We need to have that debate. Different people will land on different places about what the role is. But at the moment, and it may be different here, I think in geoscience departments around the world, we're not having those discourses about where we think we're going. So the last little bit, last leg, what can we learn from television? So what I'm getting at is I'm thinking that the kind of traditional make and sell approach that we use in science isn't being very effective because we're not really thinking about the people at the other end, the sharp end. In the case of Istanbul, the people are actually going to die. It's not going to be the scientists by and large, it's going to be ordinary people. But television does think about that. So there's a few things I just want to leave you with that I think work from television and work well in other guises. So just to remind you, really, we're into this area here. Actually, I'll bring these two things up. So really, it's trying to think, what is this sense and respond? If we are interested in this area, what should we bring to it? The wonder, the awe. So that first clip reminded us why we do geology. We do it because it's fascinating. So anyone doing PhDs here? PhDs? So think about, you're doing a PhD, thinking about your 13-year-old self and explaining to your 13-year-old self what you do, what your PhD's on. You'll probably find your 13-year-old self would not be very impressed by what you're doing. Because the reason you didn't get into geology because of that, you got into because of volcanoes or dinosaurs or whatever it is. So that big stuff. So we live in the most amazing planet, and we do kind of catch ourselves knowing this, but mostly we forget about it and we get to the detail, and we shouldn't. It's about people. This quote's from a paper I wrote with a journalist a few years ago, and these are his words, and I think they're just brilliant. It's a fact often overlooked by scientists that most other people are mostly interested in other people, and they're mostly not interested in anything else. The fact that scientists are more interested than average in things and ideas marks them out, marks you out, marks me out, is mentally unusual. People like people. They like watching the Kardashians. They like reading OK magazine and Gossip magazine because they like people. And at first glance, geology might not seem to have too many people, but of course we do. Because one thing, we have people like these guys. These are wildcat drillers in the hills of Pennsylvania. He's 90-year-old. He still drills a couple of wells a week. Extraordinary. That's his son. And they're really fascinating. They're amazing characters. And geologists deal with these kind of people all the time. So they're fascinating. And then it's about us. And what this means is the scientific method kind of takes us out of the picture. Says the people doing this stuff isn't really that important. It's all about the science. It's not really about us. And that might be true for science, but it's lousy for communication. Because we're mentally unusual. But that in an interesting way. You know, we go to foreign lands, we climb mountains, we knock a bit of rock off, we take it back to the lab, we turn it into powder, we measure something out of it, and we publish a bit. That's not normal. But it is kind of interesting. And you'll all have been at social gatherings where they say, what are you? You say, a geologist, and either that's the end of it, more or less usually that's the end of it. But if it gets through and you get to start about what you're interested in, people say, that's fascinating. Wow, I never knew that. So we're interested. And we can be the gateway to our science. And I think that's a really important thing about the passion of ourselves. I don't know a single geologist not passionate about what they do. It's about so what? It follows this one on, really. Here's a scientific method that we teach students in to be scientists. You lots and lots of knowledge and data. Then you develop some ideas, some hypotheses. And then you start working through, so collecting some data to test them. You test them, and then you get a result. And see that little point right at the bottom? That's what you want to communicate. That's the make and sell approach. Well, here's the sense and response. That's the point that the public come to you at. That's sharp bit there. Right away they say, so why should I listen to you? And if you can't get past that sharp bit there, you're finished. You're completely finished. But if you find ways to do that, you can draw them more and more and more into the detail of what you do. But it's a completely flipping around the communication triangle. And the last one, really probably the most important one, is it's not about facts, it's about stories. It's facts. It's not that facts aren't important, they are important. But just on their own, they don't really serve very much. People pick them up, use them, drop them. But if you've got a compelling story within which there are facts, then people remember the story, the narrative, that vehicle, and they remember some of the facts that that kind of carries. So it's really important to develop those narratives. And the overall thing, the overall message is that it's about engaging. It's about engaging with that very different set of people out there from the ones that's here. I've showed you this before. So we've got this make and sell mode, which I think is driven by the academic world and us pushing stuff out. We've got this, here's the public, this sense and respond mode. There is a problem, I think, with these two modes of communication, which are the two dominant, the old paradigm and the new paradigm. But they only work on the short term. So this is the short term, what we're interested in. And that's actually what the short term, what the public's interested in. They're not really interested in these longer terms. So if we're interested in trying to tell people in Istanbul that they should avoid, they're getting bombed out and there's all sorts of political trouble, but actually they should worry about an earthquake that might happen in 10 years that might kill 1 million people, that's a longer timescale. If we're trying to think about climate change and talk to people about climate change or any of these things that are much more longer term than we're used to, then I don't think those modes are actually going to work. So we need a kind of new way to communicate, I think. And really, it's this idea about time is going to be one of those kind of key things. And the mode that, if you look at the companies that are really pushing the envelope in terms of sustainability, like your Patagonias and things like that, I've got a sense of where they're going over 10, 20, 30, 40 years, or indeed maybe even with the oil and gas company, any company that has a long-term one, then one of the arguments, maybe not so much the oil and gas companies here, but it's a sense of guide and co-create. The guide bit is we have a route map. We think the science is telling us this is the direction it's going in, but we're conscious we have to keep talking to our public as we go iterating back and forth because the goals are going to change as we evolve. As that relationship's evolved, then it might go in slightly different directions. And what's key then, what all those kind of new companies that are really pushing the sustainability have got, is that a sense of purpose. And a purpose, this one, is pursuit of an ambitious, clear, enduring, and overarching goal which is motivating. So I think that if we're going to be selling climate change or selling seismic in that longer term, we need to start thinking about this new mode. And we haven't invented it yet, a new way of communicating that we're actually alongside the public, trying to get the science, trying to develop the science with them. And I think that is going to be really challenging. And with that thing that we just finished with, for me, I don't think science is enough. We need better stories. Thank you very much.